Am I audible?
Yes, sir.
Yeah. That's the question. For the given x of t, for the given x of t, sketch the following signals. Sketch the following signals. First one, x of t minus 2. Second one, x of 2t. Third one, x of t by 2. Fourth one, x of minus t. So the given x of t is signal from 0 to 4. Right on the given x of t. The outright x of t minus 2, first solution. For the given x of t, how to make it as x of t minus 2? That shifting operation. We need to shift the signal towards
Right side.
Right.
right side by
2.
right side by how many times?
2 times.
2 times. So from 4, it will shift it to 5 as well as to the 6, and then from 0, it will shift it to 1, and then 1 to the. So x of t minus 3 is from 2 to 6. 2, 3, 4, 5, 6. It will maintain the amplitude level same as 1. Afterwards, x of 2t. X of 2t means x of 2t नहीं होते.
Divide by
So divide the whole scale by 2. So 4 divided by 2, 3 divided by 2, 2 divided by 2, 1 divided by 2, 0 divided by 2. So 4 divided by 2 is 2, and here it is 1.5, 1.5, and 0. So from 0 to 2, 0, 1, 2, will maintain the amplitude level as 1 only. What about third solution? X of t by 2. T by 2 अंदर होता है. डिवाइड बाय ऑपरेशन देना होता है.
multiply.
Multiply by 2. So 4 into 2. So 4 into 2 is 8. So the signal ranges from 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8. The amplitude level as 1. And the last one is x of minus t. Minus t means
Reflection.
reflection operation. So here we have a signal ranges from 0 to 4 in the positive axis. The same will be reflected in the negative axis from minus 4 to 0. So fourth solution. X of minus t, that is from 0 to minus 4. Right on the reflection operation. That is the second signal. So for a given x of n, get x of n minus 2, x of 2n, as well as x of minus n. X of n minus 2, x of 2n. X of n minus 2 लेना होता है.
Shift towards right.
So shift right towards 2 times. So initially we have a signal at 0 at amplitude level is 0. That will be shifted to 2. So 1 time shift and 2 time shift. So at 2 it is 0. At 3 it is 1. At 4 it is 2. At 5 as well as at 6 it is 3. One, 2, 3. X of n minus 2. Afterwards, x of 2n means
Divide by 2.
divide the scale by 2. So 4 divided by 2, 3 divided by 2, 2 divided by 2, as well as 1 divided by 2. X of 2n. So 4 divided by 2 is 2. At 2, it is going to maintain the amplitude level as 3. At 2, is maintaining its amplitude level as 3. And 3 by 2 is 1.5. So because of discrete, it's not possible to write down for 1.5. And then for 2 by 2, it is 1. So it is maintaining the same amplitude level. Here we have amplitude level as 2. So the same, it is going to be maintained the amplitude level as 2 only. That is at 1. Afterwards, at 1 by 2, it's not possible to write down. At 0, it is 0. So this is x of 2n. ಸರಿ ಅರ್ಥ ಇಲ್ಲ ಅಂದ್ರೆ ಕೇಳಬೇಕು ಸುಮ್ಮನೆ ಕುತ್ಕೊಂಡ್ಬಿಡಿ The last one is x of minus n. X of minus 1 means reflection operation. X of minus n. At we have a signal at 0, so 0 is going to be retained. 1 will be reflected to the minus 1, and 2 will be reflected in the minus 2, and 3 and 4 will be reflected in the minus 3 as well as across minus 4. So 1, 2, 3. What is the next one? Precedence rule for time shifting and time scaling. Write down precedence rule for time shifting and time scaling. So precedence rule concludes. So for a equation like this, so y of t is equal to x of a t plus b. So for these kind of equations, for x of a t plus b, so it is in general format. For example, x of 3t plus 4. So for these kind of equations, so normally in the previous cases we have done with x of n minus 2, x of n plus 2, or x of t plus 2, x of t minus 2, and then x of 3t. So x of 3t we are doing separate, x of t plus 4 we did separate. But here it's a combination of both shifting as well as scaling operations. So for x of 3t plus 4, for these kind of signals, first we need to perform the shifting operation. That is, we need to perform x of t plus 4 for a given signal x of t. We need to perform the shifting operation first. Afterwards, we need to go for a scaling operation as x of 3t plus 4. So x of t plus 4 is a time shifting operation, and then we need to perform the time scaling operation. So this is called as a precedence rule. So write down. First, it is necessary to do the shifting operation. First, it is necessary to do the shifting operation, followed by the scaling operation, followed by the scaling operation. It's called as precedence rule. It's called as precedence rule. So write down an example. Just take some example for x of t. So just do some triangular signal. So we have a signal from -1 to +1 with the amplitude level as 1. So for that we need to perform x of 2t plus 3. Find x of 2t plus 3. So for x of 2t plus 3, which operation we need to do first?
Shifting operation.
So x of t plus 3. So first write down x of t plus 3. So x of 3 t plus 3 means we need to shift the signal towards
Left.
to the left by 3 times. So from +1 it will be shifted to, so from -1 it will be shifted to -2, -3 and -4. So the signal starts from -4, -4, -3 and then -2. So to maintain the amplitude level as 1. That is x of t plus 3. And then x of 2t means, so we have x of t plus 3. To make it as x of 2t plus 3, so divide the scale by
2.
so 2t means we need to divide the scale by 2. So -4 divided by 2, that is -2, and then -2 divided by 2, that is -1. So we have signal from -2 to -1 with the amplitude level as 1. So this is x of 2t plus 3. Get to the next heading. Basic continuous time signals. Basic continuous time signals. Put in the first signal. Unit step function. Unit step function. So the unit step function is defined as u of t is equal to 1 for t greater than 0 and 0 for t less than 0. U of t is equal to 1 for t greater than 0 and 0 for t less than 0. So this indicates this is the label for unit step function, that is u of t, and one concludes its amplitude level is 1 for a t greater than 0. That means from 0 to infinity, it is going to maintain its amplitude level as 1, and then from 0 to minus infinity, it is going to maintain its amplitude level as 0. So this is how we can able to write down the signal for u of t. U of t is equal to 1 for t greater than 0. So this is the t scale for greater than 0 for 0, 1, 2, 3 up to infinity. So it is going to maintain its amplitude level as 1. And it is 0 for t less than 0. For minus 1, minus 2, minus up to minus infinity, we don't have any amplitude level is equal to 0. So this is for a continuous time signal. In the same way, write down for a discrete also. So here in the heading, so write down basic continuous time signal as well as discrete time signal. Write down basic continuous time signal as well as discrete time signal. So for a discrete, so this is for a continuous, and for a discrete, write down for a discrete. U of n, so discrete is going to be denoted by u of n, that is equal to 1 for n greater than 0 and 0 for n less than 0. U of n is equal to 1 for n greater than 0. So we have a n. So at 0 it is amplitude, its amplitude is 1. At 1 its amplitude level is 1. At 2 its amplitude level is 1. At 3 its amplitude level is 1. Up to infinity, it is going to maintain its amplitude level as 1. So this is the unit step function with respect to discrete part, and this one with respect to continuous part. Write on both. And the second one, unit impulse function. Unit impulse function. The continuous time unit impulse is defined as delta of t is equal to 0. Delta of t is equal to 0 for t not equal to 0. Delta of t is equal to 0 for t not equal to 0. And the area of the delta of t, write down, and the area of delta of t, that is integral from minus infinity to plus infinity, delta of t is equal to 1. So that signal can be written as at 0, so label it as delta of t. So we are going to denote it as in terms of arrow mark with a 1. written like this. This is a signal as delta of t. So at 0, this arrow mark concludes. Write down delta of t. At arrow of the impulse function 1, arrow of the impulse function is 1 is written concludes the area under the particular pulse is equal to 1. I don't have any signal. After 0, we don't have any signal, and before 0 also we don't have any signal that is equal to 0. That is what delta of t is equal to 0 for t not equal to 0. So by theoretically we can able to write down this, that area of signal is equal to 1 means from minus t by t to plus t by 2. Its area, this particular width is equal to 1. So this is also an impulse function. But for all the problems, we are going to write like this. Here area is equal to 1, but the amplitude level is bounded to infinity. Impulse function means its amplitude level is up to infinity. So this is not amplitude level here. One, whatever the one we are observing, that is not amplitude. That's the area of the signal. But its amplitude level of this particular signal is infinity. The same way, write down for discrete signal. For a discrete unit impulse discrete function, where delta of n is equal to 1 for n is equal to 0 and for 0 for n not equal to 0. Write down. So this is a signal with respect to discrete part. The third one, ramp function for a continuous time signal, and that is denoted by R of t. Right on, ramp function is denoted by R of t is equal to t for t greater than or equal to 0 and 0 for t less than 0. R of t is equal to t for t greater than or equal to 0 and 0 for t less than 0. So write a signal for ramp. So this is a signal for ramp. So ramp signal concludes its amplitude level is 1 at t is equal to 1 and its amplitude level is 2 at t is equal to 2. The amplitude level is 3 at t is equal to 3, and so on up to infinity. So the can be written as r of t is equal to t into u of t. So we are able to write down the unit step function also. So we are able to derive the unit step function from the ramp signal. That is, by differentiating the ramp signal, we are able to extract the unit step function. Written this equation also. So r of t is equal to t into u of t. Once we derive this u of t, we can able to get the unit step function only. Derive the ramp function, you will get the unit step function. So written the ramp for discrete part, for a discrete signal, write down for a discrete. That is r of n is equal to n for n greater than or equal to 0, and 0 for n less than 0. That concludes at 0 its amplitude level is 0, at 1 its amplitude level is 1, at 2 its amplitude level is 2, at 3 its amplitude level is 3, and so on. So this is the ramp for a discrete part. The equation we can write down as r of n is equal to n into u of n. R of n is equal to n into u of n. So with this, I'm going to end the class today. All of you just enter your presence in the chat box and then you can leave the meeting.